Okay, in this video, we're going to do problems 19 to 22. Okay, this first one is a right angle trig problem, but they want you to keep things in radians. So what we know is we're missing an angle. So our angle that's missing is right here. And I know that this angle D and angle F have to be complementary. That means they're going to add up to 90. 90 degrees in radians is pi over 2. So I'm going to say angle D plus 5 pi over 12 has to equal pi over 2. Okay, why don't we make the pi over 2 into 12ths, which is 6 pi over 12. Okay, so now I know that angle D can be easily solved. So angle D is going to be 6 pi over 12 minus 5 pi over 12, which is pi over 12. So here we have pi over 12. Then now we can use SOHCAHTOA to solve for our missing sides. So let's see what's missing. I'm missing little side F, and I'm missing little side D. So from this angle's perspective, I can say that I need the opposite and I have the hypotenuse. So opposite over hypotenuse is sine. So the sine of 5 pi over 12 equals the missing side over 6.2. In my calculator, I'm going to say 6.2 times the sine of 5 pi over 12. So I'm going into radians now. Second quit. So then I'm going to say, okay, 6.2 times the sine, and I'm going to use my alpha y equals key, and I'm going to say that that is 5 pi over 12, close the parentheses, and I am getting that little side F is 5.9. If I'm going to round it to one decimal place, that's going to be 5.98. Everything's going to go up. That's going to equal 6. So little side F is going to be 6. Okay, ready to do the next one. So I'll change my color so as not to be too confusing. So now what I want to do, I know that F is 6. Let's find D. So from 5 pi over 12's perspective, I need the adjacent and I have the hypotenuse. So that's going to be cosine. So the cosine of 5 pi over 12 is going to equal the missing D over 6.2. So if you have what I have in my calculator still, I'm just going to say 6.2 times cosine. I'm just going to change the trig word from sine to cosine, and I end up getting little d is 1.6. So little d is 1.6, and that solved the triangle because I had a missing angle, which is pi over 2, and 2 missing sides. Done. Okay, let's go on to the next problem. Okay, the first thing they want me to do is to verify that this is on the unit circle. So to do that, I say negative 3/12 squared plus radical 135 over 12 squared has to equal 1 squared. So that's going to be 9 over 144 plus 135 over 144. Does that equal 1? Well, let's see. This is 144 over 144. That does indeed equal 1. So I have now verified. So this is the verification right there. Then let's try to find all the 6 trig functions. So to do that, what I will always do is set them up first. So I have sine I will call this theta, sine of theta, cosine of theta, tan of theta. And then sine goes with cosecant, cosine goes with secant, tan goes with cotan. Okay, the sine is the second value, so it's radical 135 over 12. The cosine is the first value, and that certainly can be reduced to negative 1 over 4. The tan is sine over cosine, so that's going to be a negative root 135 over 3. The 12s cancel. Okay, so let's now flip things over and get our other values. I have 12 over radical 135, which requires rationalizing. That's going to give me 12. Let's see if I can make this move over a little bit. Okay. Okay, so I can continue now. This is 12 radical 135 over 135. Secant's going to be negative 4. Cotan's going to be negative 3 over radical 135. And then rationalize that guy. And that's going to be negative 3 radical 135 over 135. And we're almost done. I want to think about this some more. This looks like this is in quadrant 2. And in quadrant 2, all students take calculus. Sine and its partner are positive. So come down here and make sure that they're the only ones that are positive, and that is indeed the case. So I know I have this correct. Okay, 21, easy peasy. It says round to the nearest degree. So mode is in degrees. And in your calculator, you say second cosine to the negative 1 of 0.4695. And you should be getting, it says to the nearest degree. So I'm getting 61.9. So that means 62 degrees is the nearest degree. Next one, second tan to the negative 1 of 3.731. Nearest degree is going to be 75 degrees. And then second sine gives me a 0.6819 is going to be 42.9 or 43 degrees. Okay, so inverse trig, key thing, because I had a desire to have it in degrees, I have to make sure that my mode is degrees. Okay, last problems. This is special triangles. By the way, 45, 45, this is your relationship. So if you know these two are equal, then, well, let's do this. Let me put this under the 45, 45. Okay, so this is the relationship. This is the A, this is the A, this is the A root 2. Then you have 30, 60, 90. I'll do it in the same orientation. This is the A, this is the 2A, this is the A root 3. You just have to know this, okay? It comes up all the time. Okay, so now match up the 30-60 triangle they're asking us about with the one I have as a model. So it looks to me like the 25 is the A root 3. I need to figure out the A. So if 25 equals A root 3, to get A by itself, I'm going to divide by root 3. Now, I'm going to have to rationalize this. Radical 3, I'm getting 25 root 3 over 3. 3 does not go into 25 evenly, so I'm just going to leave it like that. This is my A. Since I know that my side across from the 30 degrees equals A right away, I know that that is my value. Then double that. When you double it, multiply it by 2. Multiply only the 25 by 2, and you get 50 root 3 over 3. And that special triangle is done. And then the last one is a 45-45 triangle. So when I match this up, I see that a root 2 has to be 36. So if 36 equals a root 2, I need to find root 2. I have to rationalize this. When I rationalize it, I get 36 root 2 over 2. I can put 2 into 36 18 times. Both of these sides are going to be 18 root 2. And we are done. Okay? You want to know your special triangles. They are just really easy points hanging out there for you. So and that ends this video, and it ends our review for the final.